Everyone knows the second hour exam is on Wednesday. On Wednesday, exam 2 will come up on Blackboard. Now you only have 2 attempts at this exam. It's timed, so you have 60 minutes total for each attempt. You must complete this whole thing by midnight Wednesday. Actually 11:59, but whatever. Here's our modified syllabus once again. Quiz 2 is online. As soon as we finish talking tonight, you can start doing exam 2 review. And again, exam 2 is here. Exam 2 review online, excuse me, has the same format as exam number 2. It has the same questions that we're going to go over tonight, but it's presented one at a time, just like exam 2. And what I want you to do is make sure you do this so you're comfortable with the way the thing is presented and how to go forward or back or whatever. By the time we start exam 2 on Wednesday, quiz 2 must be completed. The online version of exam 2 review must be completed, and all the tutorials that you want credit for must also be completed. Any questions? All right, well, let's get on to things that are much more fun, and that is questions. We have gas in a sealed cylinder with a movable plunger. We're going to adjust that plunger so the pressure increases. Temperature remains constant. What's going to happen to the volume of the gas? This is a classic Boyle's Law problem. We remember the feather and the anvil. Little bit of pressure, lots of volume. Lots of pressure, small volume. It's an inverse relationship. Pressure goes up, volume goes down. Pressure and volume are inversely related. We increase the pressure, the volume must decrease. Any questions? All right, now we're going to do Charles. We have the same gas in the same cylinder, and we're going to increase the temperature. Pressure will remain constant. What happens to the volume? Well, remember, Charles told us that temperature and volume were directly related, directly proportional. An increase in temperature yields what change in volume? Increase gives increase. Directly proportional. And finally, our friend Avogadro. We have our same cylinder, and we just pump in more gas while we keep the pressure and the temperature the same. If we add more gas, what happens to the volume? Once again, Avogadro told us, and it really makes sense. More gas, more volume. Any questions on these three? All right. This is one of my favorite questions. You know that. This is Charles's law. Charles's law states that volume and temperature are directly proportional. Now remember what that means. That means that V directly proportional to T. V goes up, T goes up. When we talked about this in class, we said that you can always replace the proportionality sign with an equal and a constant. Therefore, V is equal to a constant times T. So, which of these tells us that? Well, is K equal to VT? That's not quite this equation, is it? V is equal to KT, not K equal to VT. So no, this one doesn't work. Our next one, we have V over T equals K. Let's multiply both sides by T. When we do that, this is just V on this side, and this is KT. Well, that sure sounds familiar. So V is a really good prospect. But this looks familiar too. V1, T1, V2, T2. No, that's Boyle's law, except V was pressure. P1, V1, P2, V2. That's Boyle's law. Charles' law looked more like this. V over T equals V over T. This guy down here, well, that's the same thing as this one written backwards. So the only one that really works is B. Once again, V is equal to K multiplied by T. Any questions? All right, one of the fun labs that we got to do before we had to leave each other was to take a spectroscope and look at lines and stuff like that. I sprayed some stuff in the flame and they were colors, whatever. This question is a classic. What is this color from? Is the actual color of the element? No, that's silly. The metal atoms absorb energy from the flame, which promotes electrons to higher quantum levels. When they return to their normal energy level, a discrete wavelength of light is produced. Now, what in the world does that really mean? Something like this. Here we have an atom. Electrons are in discrete energy levels around that. That's the period number. If you really excite some of these electrons that are down towards the core, they can be promoted up top. Now they realize that they don't belong there. They don't belong up here at all. Look around and say, where the heck am I? And so they want to go home. But they have this extra energy. So what do they do with it? As they go back home, they emit it as light. Because this is a discrete distance, this is a single wavelength of light. When we look at that light, we can see the distinct wavelengths using our apparatus. All right, so lots of words here, but that sounds convincing. Metal atoms are reacting with the flame to produce new elements. Well, that would be nice. They're reacting with carbon dioxide in the flame. No, there's no carbon dioxide in the flame. Okay, B is the correct answer. Any questions? Now, as we did this lab, we looked at the nice little lines first from the fluorescent tube and then from all the little gas discharge tubes. And we wrote down wavelengths and stuff like that for them. The Q instrument that we used was what? Was it a stethoscope? No, not a stethoscope. A spectrometer. Well, a spectrometer is kind of a really fancy version of what we used, but no, that's not what we used. A spectroscope. Yeah, that looks really familiar, doesn't it? You look through here, you point this at your source, you see your Little spectrum over here. That's a good choice, isn't it? A spectrophotometer. What the heck is that? Well, this is a baby spectrophotometer. They can get extremely expensive and very complicated, but no, we didn't use anything like that either. Clearly, we used the spectroscope. Any questions? All right, we have a strong electrolyte. Remember the lab that we did? I don't remember if we didn't actually do this one, did we? It's a shame. It's a very nice lab. But we took solutions of things, we put the probe in, and we got a reading. The higher the reading, the greater the conductivity. A strong electrolyte was something that conducted electricity. It did this because when you put it in water, it would dissolve. Yeah, it has to dissolve, doesn't it? Dissolve to form electrocytes. Any idea what an electrocyte is? An electrocyte is a specialized cell in an electric eel. And this is what generates the current that the electric eel uses to shock you. But no, it had nothing to do with conductivity. Dissolve and dissociate into ions. We said that a non-electrolyte could dissolve, but if it didn't form ions, it didn't work. So it's got to form ions. Ions are the things that actually conduct the electric current. So this one is an A and C. It has to dissolve and must dissociate. Any questions? All right, so which of the following will be a strong electrolyte? We know that it has to dissolve and it has to form ions. A, solution of olive oil and water. Well, if you've ever made salad dressing, there is no such thing as a solution of olive oil and water. It's a dispersion. It doesn't dissolve. That's the first strike against it. A solution of concentrated hydrochloric acid. Well, remember, when hydrochloric acid hits water, it dissociates to form hydronium and chloride anion. Because it's a strong acid, that means that this equilibrium lies really far this way. There's virtually no undissociated HCl left, just ions. I think by definition, that makes it a strong electrolyte. Sugar and water, well, this dissolves, but it doesn't form ions. Any questions? We have a solution, and it has a pH of 3. Now, what does that mean? Solution is basic, it's acidic, it's neutral, it has 3 moles of acid or 3 moles of base. Simple thing to remember. pH minus log hydronium. Here we have rearranged this, taken the anti-log. This is one equation you should have handy for the exam. 10 to the minus pH equals hydronium. So we simply substitute. 10 to the minus 3 is our hydronium ion concentration. That's 0.001 moles per liter. Now that's a lot of acid actually on a pH scale. Simpler thing to remember though is that If the pH is less than 7, the solution is acidic. If it's greater than 7, it's basic. This is pH 3, less than 7, it's an acidic solution. Any question? All right, we have a solution. It has a pH. It's 7. Now that's a neutral solution. We're going to take and decrease this pH from 7 to 5. What happens to hydronium? Remember, 10 to the minus pH gives us hydronium ion concentration. So this guy here is 10 to the minus 7 molar pH. So here we are, 10 to the minus 7 is hydronium where we start. 10 to the minus 5 is hydronium when we end. Which one is bigger? 10 to the minus 7, changing to 10 to the minus 5. This is clearly a bigger number, and it's larger by 100-fold, because remember, it's a log scale. So it is increased by a factor of 100. pH decreases, hydronium ion increases. On a log scale, 2 pH units is 10 squared, that's 100. And that's the answer. Any questions? All right, balancing an equation. You're going to balance an equation on the exam. Just remember, if the coefficient for any component is 1, normally we would not write it. But on Blackboard, you must write the number. Otherwise, it has nothing to grade. All right, let's start by looking here. Sodium nitrate can decompose to give sodium nitrite and oxygen. In our products, we look and we see we have 1, 2, 3, 4 oxygens, even number. On this side, we have O3, odd number. Let's fix the even odd first, and we can do that by putting a 2 in front of the sodium nitrate. That will give us 6 for our oxygens. Now, by doing that, we've added 2 sodiums and 2 nitrogens. This side, we only have 1, so let's double this as well. Now let's count up our oxygens. We have 6 total. We have used 1, 2, 3, 4. How many are left for the oxygen? O2. Only 1. And remember, if this was a real equation, you wouldn't put the 1 in, but on Blackboard, you must. Any questions? Number 12. How simple can you get? Remember, whenever you use Charles laws, or the gas laws in general, you have to use the temperature on the Kelvin scale. At 0 Kelvin, that's absolute 0. If you could ever get to absolute 0, all motion in a compound would stop. But you can't ever get there. This still sits there and wiggles even at a couple milli-degrees. But, all right, we have to be able to convert centigrade, which is what we typically measure, into Kelvin. To do that, we have a simple relationship. Centigrade plus 273 is Kelvin. So Kelvin is going to be centigrade plus 273. We're at 100 degrees centigrade. That's 373 Kelvin. Any questions? All right, we have a solution, and we are told that the hydronium ion concentration, or we want to know the hydronium ion concentration, but we know hydroxide is 1 times 10 to the minus 5. How do we do this? Well, we remember that under all conditions, hydronium multiplied by hydroxide equals this constant of 10 to the minus 14. So here we know our constant, we know hydroxide, we just have to solve for hydronium. Hydronium multiplied by the hydroxide must equal 10 to the minus 14. We do our division. 10 to the minus 14 divided by 10 to the minus 5. Make sure you have your calculator handy on Wednesday. We push the button. 1 times 10 to the minus 9 molar. Now, this test is on Blackboard, right? I don't think it's written on the slide here, but if I was to write this on Blackboard, I would say 1.00, no space, uppercase E, minus 9. Now in the question itself, it reminds you of that, called denotation. You must use an uppercase E. 1.00 E minus 9, no spaces. Any questions? Let's say we knew the pH of something and we wanted to know the pOH. Or we knew the pOH and we wanted to know the pH, whatever. The simple equation that you use for this is what? And again, please make sure you have the equation handy on Wednesday evening. It is simply pH plus pOH is always 14. Just like we said on the previous slide, hydronium ion concentration multiplied by hydroxide ion concentration is always equal to 1 times 10 to the minus 14. This is the same equation, except in log format. Any questions? All right, so what solution, which of these describes a basic solution? Basic solution. First one, pH is less than 7. Remember 2 or 3 questions ago, we reminded ourselves, if the pH is below 7, it's acidic. So that's an acidic solution. Here, hydronium times hydroxide is less than or equal to 10 to the minus 14. No, not less than or equal to. Remember, under all conditions, hydronium times hydroxide is equal to 10 to the minus 14. This is nonsense. Hydroxide is greater than hydronium. Okay, think about it. A basic solution has more hydroxide ion than it does hydronium, doesn't it? That's its definition. This is a basic solution. If you have more hydronium than hydroxide, it's acidic. More hydroxide than hydronium, it's basic. Any questions? All right, we broached the concept of reversible reactions. We know that a reaction like this, where we transfer protons back and forth, can go this way and that way. Remember, this is the forward reaction. This is called the back reaction. So we're dealing here with the forward reaction. Hydrogen sulfate plus hydrogen carbonate to give sulfate and carbonic acid. So in this, identify the conjugate acid-base pair. Now what to remember? We remember the acid is a thing that loses the proton, and when it does it, it forms the conjugate base. So the question here is, who is losing the proton? Look at the products. This is hydrogen sulfate. This is sulfate. It's missing a proton, isn't it? It has donated that hydrogen carbonate, but this is the acid form. So the conjugate acid-base pair is simply this, plus what happens after you give up the proton. Hydrogen sulfate loses a proton and forms sulfate. Number 17. Oh, we're doing a little radioactivity here. Here we have selenium 80. It is losing an alpha particle, and it forms something. What does it form? As you look at this, you notice selenium, atomic number of 34. We're going to lose 2 protons in the alpha particle. That's in the product, the atomic number is 32. We'll also lose 4 total mass units here, 2 protons and 2 neutrons. That means that the mass number must decrease by 4 units. So we pull out the periodic table. Now we know that we have this exam coming and we went to Blackboard, and if you don't have another one handy, we printed one, right? Please make sure you do that. Print it and have it there sitting in front of you. Periodic table should look like this. We are going to lose 2 mass units. So we're starting here with selenium. Atomic number is 34. If we lose 2 protons, that means the atomic number is now 32, and that's germanium. Okay, so we're dealing with germanium as a element. We have lost 4 mass units. We have made germanium 76. 76 plus 4 is 80. 32 plus 2 is, 32 plus 2 is 34. Any questions? Now, if you think back a couple questions, we answered this already, didn't we? What's correct regarding a conjugate acid-base pair? Conjugate base will have 1 less proton and 1 more negative charge. Acid will have 1 more proton and 1 less positive charge. That doesn't make sense because protons are positive, aren't they? The conjugate base is formed by reaction with hydronium. That doesn't make sense at all. And the conjugate acid is formed by reaction with hydroxide. No. So remember the basics. An acid loses a proton to form the conjugate base. Conjugate base will therefore have lost its proton, and with it, it loses the positive charge, making it one more negative. Number 19. Now, obviously, online, this is going to look a little different. I actually don't remember the format of the question, to be honest. If you have to enter things with exponentials, please make sure to read the question carefully. It'll explain one more time how to do exponential format. But okay, our pH is 12. Calculate POH, hydronium, and hydroxide. Just like the tutorial, actually. All right, pH is 12. Hydronium is going to be what? Hydronium is 10 to the minus pH. We simply substitute. 10 to the minus 12 is hydronium. And that's our answer. On Blackboard, this will be written 1.0 uppercase E minus 12. Remember, uppercase E only, no spaces. Next, let's do POH. We know pH. POH is simple because pH plus POH are always equal to 14, aren't they? So it's just subtract. 14 minus 12 is our POH, and it's 2. Now we have to get hydroxide. You could do this two ways. We know hydronium, we could divide 10 to the minus 14 by that. Or since you already did this part, and you know how to do it on your calculator, we could simply do hydroxide is equal to 10 to the minus POH. Let's substitute. Hydroxide is equal to 10 to the minus 2. On the blackboard, you would enter 1.0 uppercase E minus 2 with no spaces. Any question? The format for the online sample exam will be the same for the format for the real exam for this type of question. And finally, our last one here. If we know the molar concentration of hydronium, what else do we know? Molar concentration of hydronium, molar concentration of hydroxide. If you multiply the two together, you will get 10 to the minus 14. Yes, this is a constant. If we know the concentration of hydronium and hydroxide, we know if it's acidic or basic. Yeah. Again, if you have more hydronium than hydroxide, it's acidic. More hydroxide than hydronium, it's basic. And finally, the negative log of each. What's the negative log? pH and POH. If we add those together, it will always give us 14. All of these are correct. These are two fundamental things. Please make sure you write them down somewhere and have them handy when you take the exam. Now, the actual exam has one more question. It's an extra credit, but this doesn't. So, any questions, guys? The exam, once again, is Wednesday. It's on Blackboard, 2 attempts, 60 minutes each. You must complete it by midnight. If you're still working on it and your 60 minutes expires, Blackboard sees what you've done, gives you a score, and shuts off. So please make sure you remember this as you're doing it. Wait, well, I didn't hear that, but wait one more time. Quiz number 2 must be completed by Wednesday at 6 o'clock. The online sample exam must be completed by Wednesday at 6 o'clock. All the tutorials that you want credit for must be completed by Wednesday at 6 o'clock. Okay, it's crunch time. Do we have any questions?
Mr. Young,
Yep.
are you going to upload exam 2 at 6 o'clock?
I will be here, but the Blackboard will automatically load it at exactly 6.
Okay, thank
And
you.
then it will be up until 11:59 that evening. 2 attempts, 1 hour each. Here's a set of tutorials. Please make sure you get these done. Wednesday, 6 o'clock, it all shuts off.
Professor Young, can you go over 1, 2, and 3 again? I accidentally missed them coming in late. Or will the video be up later?
No, this is all being recorded.
Oh.
It will take probably close to an hour for Collaborate to process the recording, and then it takes a few minutes for YouTube to get it up. But the second it gets up, I promise you, I will post it online.
Okay, thank you. I can just go back later then and get
Yep.
double through those.
Yep, that'll work.
So on Wednesday, instead of signing on, we take the exam online, correct?
That's right. But I will be here. I will be here online.
Okay.
If anybody has any last second questions, I don't think anybody will, but if you do, I'll be here, and after 10 minutes or so, if nobody's around, I'll just shut it off. Okay?
Thank you, Mr. Young.
All right, guys, really good luck. As soon as I get the exams, the scores from the exams, I will send people an email as to whether or not you have to take the final. Okay? So as soon as I get this all done, that's after midnight, I will send out emails to let you know where you stand.
Okay, thank you.
All right.
Thank you.
Good night, everybody. Have a good night. Please take care. I hope everybody's healthy and happy.